I don't think I can do that. Oh, look, I can. All right. Welcome to Knox Makers Virtual Show and Share, week 1000 or something like that. We have a great presentation coming up, and we're going to skip the first person because they haven't shown up yet. So we're going to go straight to Sue, who is the second person on our slide deck, and is showing us a fabric mask sign. Hi, Sue.
Hi. Yeah, I at first called it a wall hanging. It's a fabric mask sign as well. You can go ahead and go to the next slide. And all of you know I've been making fabric masks for a while, and I tried to get as many masks as possible out of every piece of fabric. But sometimes that left 1-inch strips by 42 inches wide. In some cases, I ended up with an 8x8 square because they were supposed to be 8x9. Oops. Cut that one wrong. So since mask making is pretty much over, I decided, well, this is pretty much all I'm going to get. And then I was looking at all the empty spools of thread that were sitting there and thought, oh, that's how I can use them up. I can make a spool quilt. The next slide.
Very cute.
And every quilt has a backside. And I wasn't sure. I still had a whole bunch of fabric left over, but I didn't know if I'd have enough to do the 25 by 25 inches. So I laid it out and said, yeah, I can do this. So I started laying them out for real, picking them up, sewing them together, picking up another one. And then I found a piece that I had missed, so I tried to incorporate that in. I got it almost to the end and realized that I had a vertical seam, and I didn't like that. So I ripped some of them apart and made it so there wasn't a vertical seam from top to bottom. But in that process, I ended up with a horizontal seam across. So I worked on that a little bit until I felt I got it. So next slide. So then you have to have the binding. And I thought, what better to make the binding than the tie straps? So
Nice.
all of the double fold binding that I had pressed and ironed so hard, I pressed flat and sewed them together, making this panel, if you will. I cut this into 2.5-inch strips and then sewed them together enough to get 100+ inches so I could go all the way around the outside. As I was coming up to the point of joining them, I was totally shocked and amazed that the pink actually matched the black. I sheer luck, I don't know. Some people can, well, you should have said you planned it that way. No, I did just sheer luck. I'm still amazed that random, it worked. So I also decided along the way that I wanted to do a commemorative wall hanging and on the back side. So on my way to the space, I grabbed some Dimon fabric and a product that's supposed to help stiffen the fabric, the starch, and my double-sided fusible interfacing. The product to stiffen the fabric didn't work as well as I had hoped it would. So I pulled out the old can of starch, and I don't know if it was the store brand or if it was the age, but it didn't work really well. I cleaned up the iron as best I could, flicked the flakes off of the fabric. There were also little blue balls on the fabric from when I had used a blue batik to help protect the table and the fabric. And at that point, it was like, okay, that's it. I'm going for it. Next slide. It didn't go very well either.
Oh.
All right, so fine. And I was still determined. I came home, you know, I had all the products now. I got them all prepped. But this time I did 3 12 by 12 pieces. And I'll just say that it took all 3 and leave it at that. And if you go to the next slide, you'll see the finished product on the back side.
Is that the quilt? I thought you had photoshopped that on top to show what it was going to look like. That looks great.
Yeah, and I don't know if it was all the love that I put into the backside, and I don't know which side I prefer more, the back or the front.
That looks great too. Is it going to hang at Knox Makers?
It is, over in the fabric area. Yeah, we've been trying to figure out, well, can I hang it from the girders? That might be a fire hazard. I don't know where it will hang, but it will be residing in the fabric arts area.
Nice. Cool. That is it. Okay, well, Andrew's here now. So we're going to go back to Andrew.
Hello. I'm sorry that I was late. Hey, so I last year started frequenting the Knoxville skate park for I don't know, probably because going through like a midlife crisis, but I don't know. Anyway, the point is, while I was there, I noticed that the skate park, which was built in like, I don't know, 2009, 2010, something like that, was primarily designed for people that knew what they were doing already. And so I would watch these kids that happen to frequent there struggle to like practice something, because the only option for like a ledge or a rail was to also jump down a flight of stairs while you were practicing a ledge or rail. And so I took it upon myself to start working through a few upgrades. I think these things are exactly backwards, but we'll start here anyway, the slides. This is my latest edition. It is a 16-foot short rail that I had been asked about a few times, because it's like as low and as long as I think you could possibly want for goofing off with. So this is just inch and a half round tubing that I cut and welded at about 7.5 inches for the total height. There's a small kink in it because nothing's straight, because I don't know, the world isn't. But for the most part, it works pretty well. So that's the latest thing I've done. If you want to go next slide, Tracy. Oh no, this is the first thing I did. This was a box that I started out with. There would be a couple people that would show up with like something similar to this, and then they'd take it with them every time that they left, and everybody seemed really bummed that they always had to like when they left. So I built this thing out of pressure treated 2x material, and then just drilled out and screwed the round rail on one side and the angle iron on the other side. This thing is probably close to 200 pounds, which dissuades most people from walking off with it. And so far, it's survived there for over close to a year now, actually, without anybody stealing it, which is amazing. The other nice thing is that it's so overbuilt that it's managed to survive that long. There was a few lessons I learned along the way. I had some wheels on the far side of this, so those little holes on the front were like to throw your fingers in so you could pick it up. There were some wheels on the other side, so when you would like lift it up, above, I don't know, 30 degrees or so, it would like have wheels instead of just the corner to land on. Those wheels fell off in 2 days. So it's definitely a rough environment for things, but pressure treated and then enamel painted, and then swing back by every so often and tighten some screws, and it seems to be holding up. If you want to go to the next slide. So this was the third project that I did, the second project that I did. This was a similar rail to the first one that we saw, but this one is adjustable. So I used hitches, like a hitch receptacle from a I don't know, that you would install on a truck, and then use square tubing that fit inside of that, and just cross drilled it. So those green wing nuts there are actually a bolt and nut combination. And you spin those off and pull them out, and then you can adjust the height of this thing. Tracy, we're going to go to the next. So that's what it looks like installed now. It can go, almost nearly double that height. And then also, like, this is its lowest setting, if you will. This was probably still too tall for a lot of folks, which is why that first rail that I showed you ended up getting built. But anyway, so those are all installed over at the Tyson Skate Park if you want to go try and hurt yourself over there. And please don't sue me.
Did you put your name all over them so they know who to call?
Yeah, no.
Hopefully you didn't put Knox Makers stickers on them. They'll sue us instead.
There might be one somewhere around there. I don't know.
Okay. Thank you, Andrew. That's really neat.
Uh-huh.
Now we're going to go to Lori, who's going to talk about Barbara the Bike Blender.
Hey there.
Hi, Lori.
Hi. So this was a presentation I should have done about 2 years ago. I wanted to do it for a show and share, but at the end I'll tell you why I'm doing it now. I don't even know why I didn't do it way back then. I don't know. I was nervous. I get stage fright, but now I don't have a stage, so this is perfect. But I was asked to create a bicycle-driven blender for EarthFest in 2018. And they wanted to use it to make paper pulp. And we don't want to use any electricity, so bicycle-driven blender. And they're like, hey, Lori, can you make this happen? Because I was on one of the events committee team. I'm like, all right, let me see what I can do. I'm like, I'm with Knox Makers. I'm like, there's somebody that's going to help me with this. So, and also EarthFest that year was Make Your Mark. And it was actually celebrating makers, so which was really kind of cool. So it kind of went along that. So we started with, you can do next slide. I needed a bike. So I bought this for $10 at a garage sale. And I'm like, okay, it's a bike. We got to start with the bike. Next slide. And then we needed a name, because you got to name everything. I name everything. So Barbara, because it had to be something magical. So Barbara the Bike Blender, and it had to be something magical. So I thought of Barbara Streisand. Next slide. And we needed to figure out a way to make it decorative. So I went to McKay's bookstore and got these environmental science textbooks out of their giveaway bin. And so I got some Mod Podge and decoupaged some of Barbara. So next slide. And this is how she turned out, some prettiness going on. So that's all decoupage from the textbooks that I had. And so she's getting a little prettier. Next page. All right, and then we needed to get some tools to make it a blender. So this was actually, I had some help. I had a lot of help during this, and it kind of progressed. And this was actually Greg Toons, who was our head of our welding. He was our welding czar for a while, and he passed away a couple years ago. Actually, about 6 months after this was made. But he came up with an idea of, he got the blender for me. He's like, we're gonna do this, and it has to do, like, we'll throw a tennis ball on it, and it's gonna make it just fine. It's gonna be just fine. So these are some of the initial parts that we had for it. And then I couldn't figure out how to do this whole tennis ball thing and the stick, and I'm like, whatever. So next slide, please. So I talked to somebody who is a little more of an engineer. So Doug helped me sit down and go through all of this, and we figured out all the ratios and how much power we wanted to have and all that stuff. And I'm like, okay, we have an idea of how to do it, like technologically wise. So next slide. And we needed some parts to make things happen. So I went to Kickstand, and they gave me a bunch of, which they are a, they help take bikes and fix them up and things like that, and sell them for really inexpensively, or they give them to people who need to get to work. And they're a great thing. They used to be on Broadway. I don't know if they're there anymore, but they gave us some old parts like chains and things like that that we could use. And then next slide. Then I had to make a stand for it. So I took it to Greg's shop, Scrapulation Metalworks, and Greg made a stand for it. So we had to make it stable. We didn't want it to be able to drive around Earthfest. We wanted to make it stable so people would just pedal it. Next page. And Greg made a stand, and he decorated Barbara even more. So this is a stand made of like a whole bunch of different things. And towards the back of it, you can see there's a wheel, like a roller thing. So as you would spin, it would stay stable, and it had a bracket up underneath, and then it would be able to, you'd be able to push the wheel. So then, and Greg decorated it. He had some paint, and he's like, let's make Barbara even more special. So next slide. And isn't she gorgeous? She's like getting more and more pretty. So that was awesome. I love seeing all the colors and everything like that. Next slide. But then I realized we were looking at the design for the engineering part of it, how to make her a blender. I realized it needed a 20-to-1 back drive gearbox, right angle with no worm gear, which was going to cost probably about 65 bucks on Amazon. And this was supposed to be a very, very inexpensive, cheap, just recycled way of making this project. So I'm like, well, we can't go for the super techie thing. So I decided to ask around for a few other people for some advice of how to make it. So next one, please. Next slide. And I talked to Andrew, and he pondered some ways of making it work. We were looking at the gearbox, we were looking at everything, trying to find a way to make it work. We ended up getting a bike rack for the back of it. I think Andrew even got that for me. So we could put the blender on the back. Next slide. And we also consulted Billy. And between the three of us, we had kind of a mixture between Greg's idea and Doug's idea, and kind of made it in the middle, which was really, really good. Here we got a different blender part for it, because we actually found the other blender case was broke. So these guys helped me take apart the blender and figure out how to reconfigure it, so we could have the wheel drive the blender. Next slide. And then we had to make a base, and why not use zip ties? And so we cut a whole bunch of holes in it. I learned how to use so many different tools. I was so happy to be able to do that. I don't know how to use many of the tools there, but it was great because Andrew and Billy really showed me how to do things, and that was a great learning experience. So we drilled a bunch of holes and used zip ties to secure. Next slide. And we needed a way to drive the energy from the wheel of the bike up to the wheel of the blender. And Greg initially said tennis ball, but Billy and Andrew suggested car tires. So I went and looked for those, and those were like 25 bucks each. And I'm like, okay, I can't do this. So I went to the hobby, what is the hobby store in Farragut? I had the name.
Hobbytown?
Yeah, Hobbytown. And this nice gentleman behind the counter, I was like asking him, like, do you have any more inexpensive tires? And it needs to have a certain hole in it, and needs to have this, needs to have that. And I was like almost in tears, because I'm like, I was so frustrated. I just need to get this project done. And he's like, okay. He's like, I need to get some new tires on my car. So he went in the back, got his car, and gave me the old ones off his. Aww. So I was so excited that he did this. I'm like, it took a village to make this bike. So I had, those are the ones that I had, and they would fit perfectly for it. So next slide. And Billy tools like the screws and things like that all by himself, like custom made them. And I know he spent like 7 hours trying to tool this to make it fit to run the blender. So it was amazing how hard he worked on this for me. So I really appreciate it. So next slide. And then here she is coming together. So we got the blender on there. It's nice and secure. Then we have on the right. Oh, I had to weld some stuff on. Or what were we doing? Plasma cutting. I think we were plasma cutting something off. So I got to work with some sparks. And or we're doing something. And oh no, I was sanding something down. That's what it was. Because I'm not wearing goggles. No, I'm wearing goggles. But anyway, and then on the right side, what?
Sorry, it was Greg had taken a piece of rebar to reinforce that little piece there, and as Greg does, he just left it hanging, and it was like the biggest trip hazard, and I think it was sharp too. Like there was like 3 or 4 things where I was like, this isn't publicly accessible. So we used an angle grinder to cut off that piece of rebar that was hanging up there.
That's what
sounds about right.
And then I had to decorate a little bit, so she got a bell and some streamers. So she got to bling Barbara up a little bit more. So next slide. And then we finished her. Well, we're almost finished her. We finished up with most of the working mechanics of it. And then I got to decorate her a little bit more. So next slide. And Tracy gave me a sticker, and it said, put, and I don't have my, I'm going to go lost my glasses. It says, put the fun between your legs. And Tracy got me this awesome sticker. I could not put it on while it was at Earth Fest because it's a kid-friendly place. But oh my gosh, I love that she thought of putting it on Barbara. So we ended up using, to decorate her more, ended up using old posters and things like that from other Earth Fest and sanded her down and things like that, more decoupage. Next slide. And there she was, all dialed up, and I put some googly eyes on her because I didn't have enough things with googly eyes. And she has like a little bumper thing to green it and mean it. Next slide. Here she is on her way there to Earth Fest. She's just arriving. Next slide.
Nice.
And then they had it all set up. Continue, next slide. And we have some kids riding it, and you can actually see the paper pulp in the back that they're grinding it out to make fresh paper. And I think they were putting seeds inside the paper too, so you can plant the paper, write a note on it. And then next slide. And that's it.
Nice. So it looks like fun.
Yeah, lots of people got to ride her and do some great things. I still have Barbara. She was actually at the shop for a little while. I brought her out at home to use her for Earth Fest last year, and the weather was really bad and they didn't have things set up correctly. So she didn't get to get used last year, but I still have her in my garage. So the reason I'm mentioning Barbara now is because I need to find a home for Barbara. Because Harry and I need to have room in our garage so that we can hopefully work on a Carmen Via this fall and rebuild a car. So I don't know if we want to put her on the wall at Knox Makers, or if somebody thinks that they can use her for something. I'm going to check in. I don't know if they're going to be doing any more Earth Fest in the future because they weren't even planning on doing one this year. But if anybody would like Barbara or know what we can do with her, let me know. So, but thank you. Thank you.
Someone is suggesting a margarita party, which I'm in favor of.
Oh, yes. I think that'd be great. Because you can actually ride her. I mean, even you can ride her around. She doesn't need to be on the stand permanently either. So it'd be a really fun margarita party.
That would be an interesting drinking game.
So I can always bring her to bring her back to Knox Makers. And then if we have some room for her and want to have a margarita party, that'd be great. Just no power tools afterwards.
Right. Only bike riding.
That's right.
Thank you, Lori. That was great. It was nice remembering that project.
It was, it really took the whole space to do. It was amazing how many people helped me with that.
Nice. Thank you. Next we have Susanna, who's going to talk about her fish tank. And is probably in the camera behind her. I see you. There you are.
Yes, it's right here. It's right here. And this is the story of my fish tank, which I got last year. If you want to move to the first slide. So I got this fish tank last year in the spring, I think. A friend of mine was moving, and he had a bunch of fish tanks and couldn't take them all with him. And I took this one off of his hands. And when I got home and, you know, really gave it a thorough check out, I realized that it was in great need of repair. And one of the first things that I did is I had to reseal the sides. So like that's what you see right there is the corner of the fish tank with the silicone caulk in it. And so what I had to do is I had to scrape out all that was in there and then re-put in some more and, you know, seal it all around. And the first thing that I had to do is find out what kind of silicone was safe for fish, because not all of it is. If you use the wrong kind that, you know, is really great in your tub and, you know, doesn't cause mold or anything like that, it will kill your fish. So after doing some, yeah, that would be bad. So I looked around and I found the right kind, which if I recall correctly is silicone 1. And I got 2 tubes of that. And the first time that I put it in, I misjudged how to make the line so nice and trim. So if you look at that right there, the side that is away from the glass is nice and straight. That's because I put tape down. And that was the second time I did it. The first time that I did it, I also put tape down. What I didn't realize is that you need to take the tape off immediately after you get all of that in there. Otherwise, when you come back and it's dried or even partially dried and you peel that tape off, it is kind of like taffy or bubble gum, and it pulls out these long strings and stuff. So I did that, and then, you know, I was back to square one and I had to scrape off all of the silicone again, only this time, it being a lot fresher, it was much more of a pain. I really had to get in there with like razor blades and stuff and get it all off, because the internet says that if you don't have it completely cleaned, the new silicone will not stick. It's like, you know, we like just our plain glass, no other silicone, we don't get along. So I did that, and, you know, I scraped it all off, and you scrape it with a razor blade, and then you wipe it down, you know, several times with acetone to make sure that you get it all off. And then you lie down on your back for a little while and breathe and watch the little pretty pictures after breathing in all that acetone and the silicone, which smells like vinegar, but it's not vinegar and is like not good for you. And once I got all that done, I put in the silicone the second time, and I had my tape all in there. And this time I took it off immediately, and voila, it's great. And after I let it cure for like 2 weeks, and then I put water in it, and like it has held. Yay silicone. Next slide. The other thing that I had to do, and I did this a little bit before I did the silicone, is the along the base and the top of the tank, but the problem was really at the base. There were some cracks in the plastic surround, just because it was really old and this plastic is starting to get brittle. And after a little thought and some good advice from Simone, I used some epoxy to just put it together. And like, I'm not like super great and awesome with epoxy, but you know what? It's holding together. Awesome. And it's right here at the front. So, you know, I can just look at it and be like, hey, I fixed this with epoxy. That's so awesome. Next slide. So the next thing that I had to do to have it all sealed off is it needed a top so the fish won't jump out, and it slows down your evaporation rate, which is nice because having to, you know, be like ready to fill it up with water all the time gets a little bit annoying. And what I did is I measured out the area that I needed, and I got some acrylic, and I got some little pieces, which I'll show in later slides, from Amazon to hold it all together. And I laser cut it with the help of John Dale and Charles and Viola. In fact, really, they should probably be presenting this project as part of the project, because, like, you know, I kind of stood there with my, you know, thumbs in my pockets, you know, and said, wow, isn't this awesome? Look at what you can do with a laser cutter if you know what to do. Next slide. So that's the handle that I got from Amazon, which you can get, and it's got like a little sticky pad on it, and that's the handle to lift open the slots. The way that I did the tops is there's like 3 inches in the front, and then the back is like 6 inches, and there's a hinge in there, so I can lift up the front to feed the fish, but I don't have to pull off the entire lid. If you go to the next slide, that is the hinge, which I also got from Amazon. And I got it in like a long strip, and I cut it down into size, and then you just slide the pieces of acrylic on either side. And to make sure that it works out, you want to make sure that you reduce that amount in your measurements when you're making your pieces, just in case I didn't make that mistake, but I almost made that mistake. So, you know, just there for everybody to know. Now, one thing that I wasn't aware of, which you'll see in the next slide, is you can see how the corners of that are tipped up considerably. A little factoid that I learned about acrylic after I had this all made and was all fitting in and looks nice is that it has some weird properties when it's around a lot of water, and I don't think it exactly absorbs it, but there's something that happens, and over time, the shape will sort of bow out of place, like you see there, and it kind of flips up on the sides. And after reading around some of the aquarium sites, there's general agreement that, yes, this is a problem with acrylic. And what you can do is flip them over on a regular basis, which I did earlier today. So I can lift this up and you can see that, maybe you can see that they're kind of bowed a little bit, but up in the other direction right now. And over the course of the next 2 weeks, it will flatten out and it will reverse. And then it will be time to flip them over again. And so, like, that's how it is for right now. Someday I may recut them with glass, because the internet is in agreement that glass does not change its shape so easily. But they're also in agreement that it's a pain to cut and very, very sharp, and it can become a bleedy incident for you if you're not you know, very skilled with glass. So I'm gonna put that off for the future right now, and I'm gonna keep flipping my lid, you know, every couple of weeks or so. And this is my fish tank. Most of the time, I'm just gonna look at my fish and feed them on a regular basis. And that's my project.
Very lovely. How often do you have to flip the acrylic?
About every 2 weeks. That's about how long it takes, and the center of it will become so low that it's touching the water, and the sides of it, the corners of it are pointed up, like in that picture right there.
So it's not just aesthetics, it's like actually dipping into the water. That's not good.
Yeah, it's dipping into the water, and so like when I put the fish food in, you know, it will move in different directions because the lid is, you know, on the surface of the water, and so it's not ideal. It's not ideal, but you know, there it is.
It works for now.
It's working for now.
Okay, good job. Thank you. And next we have Simone.
This is right here.
Yeah, I'm right here. Over the weekend, last weekend, I made 2 different embroidery hats, for one for my dad and one for a friend. And I did that on my home embroidery machine, which is just like a sewing machine, embroidery machine combo. And how I did it is I took the smallest hoop this size, and I shoved the hat on it and I pinned it to stabilizer so that it would stay put while I embroidered it, because there's not really an ideal way to embroider a hat on a home sewing machine because they're a weird shape and the brim sort of gets in the way. And you have to be really careful with the brim, because I've had it break parts on my sewing machine. The sewing machine will move and it won't stop moving, so it will break through any plastic parts that are there that don't physically stop the gears in it. But this is the second one I made. It's a reference to a joke one of my friends made in a Smash Brothers fan fiction he wrote. It's funny if you know the fan fiction, but it's kind of like a weird thing. And it's I made the design in I don't remember the name of my embroidery program, but I made it in an embroidery program, and it is the Impact font, digitized. It looked pretty nice. It did 2 different passes. It did a fill stitch, and then it did I don't know what that stitch is called. Is that like a satin stitch?
Yeah, that is a satin
Yeah,
stitch.
it's satin stitched over top of the fill, so it doesn't like curl up into itself, because the satin stitching is so wide. Impact is a great font. Yes, I agree with John Dale. It's a great font. It makes a statement. If you go to the next slide, I also made a Waffle House hat. It didn't turn out as well because my needle was dull, and I didn't realize that until halfway through. And when I replaced it, I was like, wow, this looks way better now. But it turned out all right. That program doesn't like to keep the colors consistent, so I kind of have to guess which color thread to use based on the picture, and that can get really hard depending on how many different colors are in the embroidery and how close together they are. That's my dad's foot. Yeah. This one did black first and then did yellow over top of it, and I don't know why I did that, but it turned out pretty good. And then on the back, if you go to the next slide, it says the best pancakes in the South. You can take that however you want. Waffle House doesn't make pancakes. Those are my hats.
I like them. I like the Waffle House. It looks sort of like handwritten the way it turned out. I like it. Or maybe that's just the photo, but I like it.
Yeah, it looks a lot less perfect than the other one. It's got its quirks. But
so does Waffle House.
Yes. Yes.
Thank you very much, Simone. Next we have Martin with more spin welding.
This is a continuation of last week's show and share. To recap, I noticed this mouthwash bottle that had this dispensing feature, and I said, ooh, I could use that to dispense the polymer emulsion that I use for a couple of sculpture processes for Portland-based surface bonding cement and for gypsum-based aqua resin. Need tiny batches sometimes, a succession of tiny batches, and either I fill a lot of little bottles ahead of time, or I could just squirt this and get a consistent volume each time. But I couldn't figure out a way to get my liquid into the bottle to be able to squeeze it to fill this up. Couldn't figure out how to get that assembly out, so I figured I needed to add a port to the side, and that made me think, well, this is PETE. How about I use thermoplastic spin welding that I had briefly read about and thought, well, that sounds easy. That shouldn't be hard. Next slide, please. Turned out it was harder than I thought. I knew there were several things I was getting wrong about my assembly just with the tools and parts that I had on hand, but I went ahead anyway. You can see the little T-nut on the outside of the cap at the top, and as I showed last week, I spun it, and the theory is that the parent materials on each side melt from the friction, and then you stop and they freeze together, mixing the parent material. So it's a true weld without having to add any filler rod. And I thought that was what had happened here, but when I touched it, it just fell off because it was just spot welded. So I figured we need to go to the next slide and see where we go next. Got the parts right this time, I think. If you can imagine the bottle to the left and this little thin sheet, imagine that being the top of that white cap. So I'll put the T-nut on the inside, and this is the prong style, and would go ahead and knock it through, puncture the cap, then have the hex bolt on the outside, have the little nut driver bit for a drill, and that way when I'm, instead of the way I did it before where my rotations were opposite and it sort of spun welded in a little bit before it all fell apart because I was spinning against myself. So this way, the more torque you put on it, the tighter it all this assembly fits together, and then you really start spinning the cap and everything that's attached to it in earnest. Next slide. So I cranked the rotation to it and said, well, that really, not only did it weld, but I got a bonus. It cut out the section of the wall of the bottle that I wasn't counting on. I thought I'd have to drill that out. But next slide. That's all it did. It wasn't welded at all. So I need to not take this process for granted. I actually need to look up how to do the spin welding, which will be interesting for something else, but not for this project. So I titled this last week as the thermoplastic spin welding and spin weld 2, but now we're officially changing the title, whereas the dispenser bottle is going to be an example of thermoplastic spin welding. The project is now the dispenser bottle, and the thermoplastic spin welding is an example of one way not to do that, or at least not the way I did it. So next, going to do it a different way, but I still need this bottleneck, but no way I'm going to use this one because did that assembly with the rotation so well that it tightened the bottleneck so well into the cap that there wasn't any way I was going to get it out. Next slide. So where am I going to get another bottleneck? Well, this is pretty useless bottle now that punched the hole in. So let's just saw that bottleneck off again with my 62-year-old 1958 X-Acto razor saw, dependable tool. Next slide. And it just so happens that one of those serendipitous alignments that the hole saw that I had happened to just about perfectly fit the hole that was in the bottleneck. Next. So I hole sawed the hole in the side of not just a test bottle, but the actual mouthwash bottle. And then now I got all these plastic sawdust. So next slide. So we just vacuum those out, and I should be ready to go. But next slide. What's this goop in the bottom? Oh yeah, it's a mouthwash bottle. That's mouthwash. And the whole point of putting this port in the side was that I couldn't get to the inside to clean it out and to put my liquid in. So I have to rinse this out. Next. And then blow dry it. Next. And then I have to trim up the hole. I know it would work without it being a little bit rounder, but I did want to point out that I'm using the number 11 X-Acto blade, quote, upside down. And this way I can control it a lot better. I can see the action, I can see what I'm cutting. And I'm not saying that every tool in your toolbox you should try using upside down to see if it works better, But sometimes there's some things like in a previous show and share last year, showed that with a bent handled offset pin snips, if you turn it up the other way so the logo is upside down, then you can see what you're doing, and often it's more ergonomic, not twist your wrist into weird shapes to cut. So just be aware there can be other options. Okay, but what I'm going to do now, I have this, what is this mysterious second example of a process? Next. Well, of course, it's hot glue. Next. And looked like a pretty good hot glue seam. Next. But will it hold water? But more equally important with holding it water is, will it hold air? Because when I put the cap on this side port and the cap off of the top little dispenser area, then it needs to be sealed well enough against air so that when I squeeze the bottle, I'm compressing the air on the inside. There's atmospheric pressure on the top, so the water is going to be forced up the little tube and up into the neck at the top of the dispenser area. Next. And yes, indeed, it holds water. It holds water, but I started thinking it goes up the tiny tube, and next comes out the tiny hole at the fill line, and then if you squeeze hard enough, it'll flow above that. But then when you release the pressure, then it backflows down the tube. I wanted to put a polymer emulsion in that. The way polymer emulsions work, it's kind of glorified Elmer's glue. It's the little water molecules, when they go away, because they're bound with Portland or or if they evaporate, then the other polymer bits start cross-linking, and you get a plastic film or rubbery film on whatever surface they happen to be on at that moment. So I could get one work session, maybe 2 or 3, maybe 4 before this hole in the tiny tube completely plugs up. So that's the second example of solving my problem of getting this dispenser. So what else would work? Next. How about this, which was what I had really thought about months ago or maybe years ago, but this is a petroleum product, and I want to use this water-based product. I thought, well, oil and water don't mix, so I have to not even consider that. But just think of all the lather, rinse, and repeat steps that I would have been able to complete during the time I was doing this whole other project. And this is, I'm not putting food in there or a beverage or medicine. It's not rocket surgery. So that would be fine to just clean out this bottle. And it's got more calibrations up at the little dispenser part. Already has a second port that's bigger than I can pour my liquid in. And it's got a much bigger tube to go between the two cavities. So yes, eventually, after dozens or hundreds of uses, maybe that will completely plug up. But I would get a lot of use out of it. So, but I don't begrudge the time I spent on the other processes. A little more hot glue practice, and especially the spin welding, which is intriguing, and not for this project, for something else, but I need to read the friendly manual and find out how to do that and be able to show and share that sometime. Any questions?
I like it.
Thanks.
Thank you, Martin.
Mm-hmm.
And last up, we have Zach. I see you there, Zach.
Working on the camera here.
Yeah. I like listening to Martin's projects because they always take a really crazy route that is not often talked about. When it happens with every project, but usually that part's edited out. All right, ready, Zach? I see you.
Yes, I am.
All right.
All right, this is my MP CNC build. I've been wanting to make a CNC machine at the house for about 5 years now. Finally, I've gotten around to figuring out the best way to do it. Still a work in progress. This is the overlay of what I have thus far. Next slide, please. Still the overlay. You can see my x-axis on either side with the bearings already mounted for my y-axis gantry. It is roughly 48 inches long, and it's going to be about 36 inches wide. It's going to be run by 3 NEMA 23 stepper motors, excluding the z-axis. Once I figure out how to wire those up to the Arduino Mega board there. Next slide, please. The NEMA 23 motors, I'm going to try and put one y-axis, or one x-axis and one y-axis motor, which will let the third motor be used for possibly a fourth axis, if possible. I don't know if GRBL will allow that or not. Still a learning process as I go, but figured I'd make my 3D printers work instead of doing just little trinkets and other small little things. Next slide, please. Here are the 4 pieces that will go on my x-axis or y-axis gantry. It will have a couple bell bearings with some 5/16 18 bolts through it, along with bearings to ride horizontally on the 1-inch tubing from Home Depot. Next slide, please. There you can see how the bearings ride on the gantry system, and also see where I'll be able to hook up my y-axis to the 3D printed parts. It's printed quickly, 50% infill, and it's printed out of PETG plastic, so it's got a decently high melt temperature and a decent amount of flex with little shattering, unlike PLA plastic. Next slide, please. Here you see the y-axis that will actually be connected to those, and they have the other axis squared tubing holes that will be mounted to the, or that will hold my z-axis and travel back and forth. Still waiting on that paint to dry. For some reason it's taking forever. Next picture, please. Here you see it's an open build STL file, which those will hold some special V-groove bearings and will run on the aluminum 2020 extrusion that you actually see in the top corner there. I will have a belt running all the way around that, connecting to the left and right side, attached to some tensioners and the motor, and hopefully that will be able to move my gantry and my motors. This is not the original build that I got the parts from, or the idea from. It's just a slightly different setup. But those use concentric nuts to allow me to adjust the tension on the 2020 aluminum extrusion to let it move back and forth smoothly. Next slide, please. Here is the Mega 2560 project starter board that I ended up buying. I've got that and a Arduino Uno that I need to start playing around with and try and learn and figure out best way to do that, which is actually how I found you guys at Knox Makers, because I have a feeling that you guys can actually help with me learning how to do that, along with all my other hobbies, such as building and coming up with designs like this. Next slide, please. This is the G2 belt, I think it is. GT2 or something. It's a 6mm belt, and that's what I have planned to run my gantry systems instead of a ball screw for my X and Y axis. I'm going to use this because it is slightly cheaper, and I'm trying to make this to where I can do some 3D machining at the house, because I would like to work on some 3D machining and epoxy projects to make really cool designs and countertops, stuff like that. And that's the whole idea behind this build, is just being able to have a CNC that I really enjoy running at the house. So, there any more slides left?
Yes.
Here is a close-up of the Y-axis. To get my 2020 aluminum extrusion through that, I'm going to have to modify and cut a hole in the center of that, so the extrusion will be able to sit on that, and I'm going to mount the motor sideways on it instead of sticking straight out from the edge. That way it doesn't have like a lot of overhang, and reduces the risk of anything getting caught on the motor as it moves back and forth, whatever that may be. So, next slide.
I think that was the last one.
Ah, cool.
That's really neat. I can't wait to see when it's all put together and working.
Me too.
Right? Tim says that he built one with conduit and you have to reinforce it. And he likes the extruded aluminum.
I've looked into doing that design. I just don't like how it stands over top of the it stands over top of the project, and that makes it top heavy, I guess. Or that's my theory anyway.
Cool. What are you going to make with your CNC machine? Or is the CNC machine just going to be forever, the project forever?
The CNC machine is going to be mainly used for 3D machining. I really enjoy pushing my limits with CNC work, because that's what I do for a career. So I'd like to be able to mess with it at the house and not actually at just my job. That way I can expand that knowledge.
Very nice. Thank you very much.
Thank you.
All right, for announcements tonight, we've been doing virtual classes for a couple weeks now, and they seem to be going okay. We have a FreeCAD class coming up this Saturday at 11 a.m. That is being taught by one of our former members who showed something a couple weeks ago, Brian Manifold, and we all hounded him until he decided to teach a class for us. So he'll be doing that on Saturday. It is free for members, and non-members are $5. So, and it will be using this platform. If you sign up, you will get a link to the room, so you can join that. And that's this Saturday. And you can sign up on our events calendar on our website. We're also trying to get, even though the shop is closed to public classes and bigger in-person classes, we're trying to help people get authorized on the tools that they want to. If you want to be authorized on a certain tool or area, you should contact the czar of that area in Mattermost. I know that the woodworking and metalworking are trying to help people out. Billy's willing to do one-on-one classes for machining. And the laser cutting, I'm actually thinking about doing a class next week in person at the space. So you should look for that on the calendar. Otherwise, talk to the czar of the area in Mattermost. The building, again, last weekend was working. I think the only thing left is putting the trim on. Is Andrew still here to correct me? No. So I can say whatever I want about it. I'm pretty that the last thing is the trim. It's almost done. They just have to get the last few things done and then can start moving stuff in and using it and teaching blacksmithing classes even. If you are interested in helping, there's a channel on Mattermost called Building, and also Andrew Messersmith is on there. He spoke earlier, and he can direct you if you want to help. Unskilled labor is also welcome. Even if you have no idea how to build a building, there's definitely things to do. So you should hit Andrew up if you're interested in that. And that is the end of our presentation tonight.